All right, let's talk about something we all use, but maybe don't think about too much: medicine. We're going to pull back the curtain on the secret life of a drug.
I mean, have you ever really stopped to wonder about this? You pop a tiny pill for a headache, right? And somehow, it travels through this incredibly complex highway system that is your body, ignores your ankle, your elbow, everything else, and goes straight to your head to do its job. How on earth does it know where to go and what to do?
Well, it's not magic, even though it kind of feels like it. The whole process is really a story in two parts. And yeah, they've got these long scientific names, but trust me, the context behind them are actually pretty straightforward. So let's break it down. On one hand, you've got something called pharmacokinetics. Just think of that as the drug's journey. And on the other hand, you have pharmacodynamics, which is the drug's mission. The journey and the mission. Honestly, if you can just hang on to those two ideas, you'll pretty much understand the secret of how any medicine works. Okay, so let's tackle part one first, the journey. This whole section is about what your body does to the drug, right from the second you take it. Right, so that fancy word again is pharmacokinetics. Scientists just call it PK to make it easier. And all it is, really, is the study of how a drug moves through the body. It's like its travel diary from the very beginning to the very end. And this journey isn't just a random road trip. Nope, it follows a very clear four-stage plan. And luckily for us, there is a handy little acronym that describes it perfectly: ADME.
So what does ADME stand for? Well, A is for absorption, that's step one, getting the drug into your bloodstream. Then D for distribution. It's got to travel around, right? So it spreads through your tissues. Next up is M for metabolism. This is where your body, and especially your liver, starts to break down and change the drug. And finally, E for elimination. Your body has to get rid of it, and that's usually the job of your kidneys. So absorption, distribution, metabolism, elimination. ADME. That's the whole journey, right there.
Okay, so why do we care about all this? Here's the key takeaway. The entire ADME journey is what determines how much of that drug is actually active in your system at any given time. It controls the drug's concentration. And that concentration level, well, that is everything. It has to be just right for the drug to even have a chance to do its job. All right, makes sense? The drug has made the journey, it's arrived. Now what? Well, that brings us to part two, the mission. This is where we flip the whole thing around. Instead of what the body does to the drug, now we're talking about what the drug does to the body. And this is the world of that other fancy term, pharmacodynamics, or just PD. If PK was the delivery truck getting the package to the house, PD is what's in the package and what it does. It's the study of what the drug's effects actually are and the nitty-gritty of how it pulls them off. So what is this mission exactly? Well, you have to zoom way, way in. The drug's whole purpose is to find a specific target in your body. You can think of these targets like tiny little locks on your cells, maybe a cell receptor, for example. The drug is designed to be the perfect key for that specific lock. When the key fits into the lock, it turns, and that triggers some kind of change or response. That's it. That's the mission. Now, to figure out how good a drug is at its mission, we ask three big questions. First, there's potency. Basically, how much of the drug do we need to see an effect? Then there's efficacy. What's the biggest possible effect this drug can have? What's its maximum power? And then, super importantly, we have the therapeutic index. This is all about safety. It asks, what's the window between a dose that helps you and a dose that could actually harm you? Okay, so potency and efficacy. People mix these up all the time, so let's clear it up. Look at this chart. You've got drug A and drug B. See how they both reach the exact same maximum effect? That means they have the same efficacy. But notice how drug A gets the job done with a much smaller dose? That means drug A is more potent. Now, more potent doesn't mean it's a better drug, not at all. It just means you need less of it to get the same result. Okay, so we've got the journey, that's our PK, and we've got the mission, that's PD. Now for the really cool part. We're going to see how the journey meets the mission and put this whole puzzle together. This really sums it up perfectly. Pharmacogenetics governs how the drug reaches its target, while pharmacodynamics governs how it interacts with that target. It's just so elegant, right? One is about getting there, the other is about what happens once it arrives. Let's think about it like this. PK, the journey, is all about the delivery. The big question it answers is, are we getting the right amount of our drug to the right spot at exactly the right time? Then you have PD, the mission, which is all about the action. It asks, okay, it's here. Now, is it actually doing what it's supposed to do? Delivery, and then action. And here is the absolute bottom line. You cannot have one without the other. They are completely linked. You could have the most brilliant drug in the world, a perfect key for the lock, but if its journey is messed up and it never gets to that lock, it's useless. The journey is what makes the mission possible, period. So, this is all really cool science, for sure. But, so what? Why does any of this actually matter to you and me? Let's bring it out of the lab and into the real world. Well, knowing all about a drug's journey and its mission is literally how your doctor decides on the right dose for you. It's why one medicine is a pill you swallow and another has to be an injection. It's the reason a dose is different for a kid than it is for an adult, or for someone whose liver or kidneys aren't working perfectly. At the end of the day, all this science is what stands between us and chaos. It's how we make sure our medicines are both safe and effective. And that really leaves us with one final kind of mind-blowing thought. As we get better and better at understanding our own unique genetics, just imagine, how can we use this science, this deep understanding of the journey and the mission, to create medicines that are perfectly 100% tailored just for you? That right there is the promise of personalized medicine. And it's an exciting thing to think about.